quick screen recording from today, review what we talked about today, and set you up for success for homework. I'll give people a heads up when they can probably bug out if they weren't in class today, but you can look at any of it if you like. So today we reviewed what happened in Unit 1, Activity 1, disconnecting a wire from a loop. We had two bulbs and a 3-cell battery pack and disconnected the wire at various parts all around the loop and disconnected a cell or a bulb. And in any of those cases, whether we disconnected a wire, a cell, or a bulb, both bulbs became unlit at the same time. We came up with two new terms today, an open loop and a closed loop. A closed loop is an arrangement of batteries, bulbs, and wires that allow the bulbs to light. There can be no breaks in the loop for that to happen. It has to be a continuous loop of conductive material in order for the bulbs to light, and both ends of the battery pack have to be part of the loop. Secondly, an open loop would be an arrangement of batteries, bulbs, and wires that does not allow the bulbs to light, which would be anything that has a break, either by disconnecting a wire, removing a bulb from a socket, removing a cell, or putting some sort of non-conductive material in the loop as well. And like when you just disconnect a wire, that puts air in the loop, and that would not allow the bulbs to light. Secondly, we reviewed what happened with our consensus for activities 2 and 3, which looked at what kinds of things when we put in the loop allow the bulbs to light, and we found that conductors, which are typically metals, allow the bulbs to light, but when we put non-metals in the loop, which are considered insulators, or typically are insulators, they do not allow the bulbs to light. So what were some conductors? Paper clips, pennies, aluminum foil. Some conductors that were not metals that allowed the bulbs to light included silicon and salt water. Also pencil lead, which has no lead in it, it's just graphite, ground up carbon, allowed the bulbs to light. So those are all conductors versus insulators, which were typically paper and glass materials, plastics, shoelaces, plant materials frequently are insulators, and that did not allow the bulbs to light. We did also discuss that conductors or insulators are on opposite ends of a spectrum, and some things are strong conductors, some things are weak conductors, some strong insulators, some weak insulators, and sometimes it depends on the strength of the circuit that you put them into. Additionally, today during class, we tried to light a bulb with a cell and a wire. If we assume that this is a battery and we've got the positive terminal, well, I should have drawn it this way. If the positive terminal is here and the negative terminal of the cell is here, how would we have to, oh, I hit the wrong button, I guess. Okay. How would we have to connect a wire and a bulb to this to get the bulb to light? Well, if we put the tip of the bulb on the positive terminal, make sure we understand, here's the glass of the bulb, here's the thread of the bulbs, the horizontal line, which these are all off a little bit. This horizontal line here is supposed to be the black ring, and then below that we have the tip of the bulb. So the tip of the bulb is touching the positive terminal. I'm going to go ahead and back off all of those adjustments. And then how would we have to connect a single wire to get the bulbs to light? Well, both ends of the battery pack have to be involved. Right now, the tip of the bulb is already touching the positive end, so if we put the wire on the negative end of the battery and touch the other end of the wire to the threads of the bulb, this bulb will light. So we have the threads and the tip of the bulb involved in the positive and negative terminal of the battery pack. There were 3 additional ways to get the bulb to light with just a cell and a wire. You should test those out in class and see if you can come up with those. So on to the homework, and this is really what I made this video for. The first problem on Unit 1, Worksheet 1 says, which of the following bulbs would light first? Bulbs A, B, or C. Notice that the negative end of the battery pack and the positive end of the battery pack are both included in our loop. And we have wires going from bulb A to bulb B to bulb C. They're all part of a continuous loop of conductive material. A CCP, so all bulbs would light and they would all light at the same time. Well, if you look way down in the bottom right-hand corner, it says use a colored pencil to go back and trace the continuous conducting path through numbers 1, 2, 3, and 4. In this case, if we start at the positive term of the battery, our continuous conductive path goes from the positive term of the battery pack through the wire, through the bulb. Because these sockets don't show the individual bulb, we can just go straight through the socket. If the parts of the bulb are shown, you should go through the individual parts of the bulb like we did in class. And then through each additional socket and bulb. And then once it gets to the battery pack, it has to go through the blue bolt, across the cell. It touches the wire that connects the cells from one to the next along the edges, and that's a full loop. And so that's what they mean about making the CCP, or continuous conducting path loop. The other thing we did today is we took a look at a dissected light bulb today. I guess this is it. And again, this is review material, mostly for people who are not here. Things that were included in this is actually a little too large to manipulate. Let's see if I can shrink it down, and the answer is no. Okay, we'll get rid of that. And go back to this. So what parts of the bulb do we have here? Well, obviously this part up here is just the glass of the bulb, right? And if we go down a little bit lower, I'm going to make this in green as well because it's made of an insulated material. This is the black ring. The black ring is made of ceramic material, and in all honesty, black rings are not always black. They can be purple or blue or brown or whatever. Let's talk about the conductors in our loop. First of all, we've got the metal part here that we screwed into the socket, and those are called the threads, or threaded section. Above that, we have that metal blemish, the solder point, which glues the metal threads to the support wire that goes up to the filament. In most of the dissected bulbs we looked at in class today, the filament was broken, and that goes down to the other support wire, which went all the way down straight through the center of the black ring and touching the tip before it left the bulb. And then, so these two wires here that hold up the filament are called support wires or supporting wires. And those are conductors. The tip is also a conductor. The threaded section is a conductor. The solder point is a conductor. The filament is a conductor. So if the stuff moving through the wires needed to get through this continuous conducting path we have would include getting to the threads, and from the threads to the solder point, which is glued with metal to the support wires, up the support wire, across the filament, which is made of tungsten, another kind of metal, down the metal supporting wires, not touching the black ring, but going through a hole in the middle of it, out the tip, and then out through the base of the socket. That would be the path through the bulb, or the continuous conducting path that goes through the bulb. Likewise, that could go through the opposite direction as well, and through the tip, up the support wire, across the filament, down the other support wire, through the solder point, and out the threads that way. I hope that helps.